Hi there, my name is Austin. I'm a software engineer who loves to program and loves games, and I'm here to talk to you a little bit today about heightmaps. Recently, I have been looking into the Bevy game engine using, which is a game engine, open source, programmed in Rust, and I'm trying to build my own game, but I'm learning a lot as I go along. Bevy is not a full-fledged engine; it's very much in beta slash alpha, really, and there's a lot of things you have to do manually. So I have been excited to learn a lot about game development, and this is one of the things I learned recently that I thought I would share, and that's what is a height map. So a couple of things you'll need to know going into this video. You'll have to know what a vertex is. Here's a little graph of a vertex. A vertex is basically a point in space. And I learned that in the context of game development, a vertex can actually hold more information than just like the X, Y, Z coordinates. It can hold other things, which I haven't learned too much about yet, but it seems that it's more than that. But for the purposes of this video, you'll just need to know that a vertex is a 3D point in space. It tells you the X, Y, Z coordinates. Speaking of which, you'll have to understand the XYZ coordinates. So that means you'll have to know 3D coordinates. Um, and, a coordinate plane can look a little something like this. You have the X, and in this case, Z axes, which are the 2D part of the plane, if you will. Then you have the Y coordinate, which is actually the height at any point. So if you were sleeping through algebra in high school, you may want to go back and review that just a little bit to remind yourself, oh yeah, what's X and Y and what's XYZ and how does that work? In the Bevy game engine specifically, the Y-axis represents the height. So how far, a particular point is above the surface of the land, if you will. And a third thing you'll kind of have to know is RGB. What are RGB coordinates? And what do they mean? So RGB represents red. It stands for red, green, and blue, and it's a way of defining colors. So if you've ever programmed a website, you'll be pretty familiar with these because you'll have those hexadecimal codes, which tell you what the color is. All right. So as I mentioned earlier, we'll be using Rust and Bevy. Um, and let's start off with what is a height map. So this image here, this is a height map. This is a 2D image. This is also a height map that I created myself. And on this height map, you can see it's like we're looking down from the sky as a bird. We're looking down at this plane. In this case, it's the Lauterbrunnen Valley in Switzerland, which has very deep gorges. So you can see these high mountain peaks are very light. So the wider areas are the tall peaks, and then the lower areas, as they go down, are the darker pieces here. So you can see, like, right here in the center is where we have the very deepest part of this valley, where there's these like sheer, steep cliffs. And that using this height map, we can turn it into something like this. This is like a 3D screenshot of that particular height map that I created myself. And you can see sort of some of the similarities with this image. We have this deep gorge here in the middle with these very high peaks here, and then there's these other formations as well that kind of correspond to these places on the map. So how do we do that? So for this example, I'm going to use this particular height map just because it's a lot simpler, it's a lot smaller. And you can see on the left here we have the white, which is going to represent the highest peaks. Then on the right we have this darker color, which is going to represent the lowest peaks that can possibly occur in our particular map. And what is this height map? So this height map is it's just a PNG image. You can see here this called progressive height map.png is what I've called it. So what we want to do is we want to extract the RGB data from this particular image. And there's a couple ways to do that. In my case, I'm actually using the Bevy game engine. It has a couple built-in tools for this. There's also a crate called, I think, just image that you could use to extract that RGB data. And what we're going to do is we're going to extract it and turn each of those colors into a number, basically, that represents our height here. So in order to do that, we have to write some code, which I've done. Let me see if I can find that file here. Excellent. So yeah, here we are. I have a couple methods I've used for this, but the main one is called normalize RGB values, which I've just created. And what it does is it accepts the data from the image. And in this case, I've turned the data, or Bevy has helped me turn that data into a single vector of values. So if you remember from earlier, each R or G or B value can only be from 0 to 255. It represents, how strong of a color, or what color exactly it is. For all gray colors, grayscale colors, R and G and B will be equal to each other. So you can have 000, or you can have 255, 255, 255. That represents white. The latter represents, a dark black. The blackest black it could be, basically. And so here you have what I'm doing is I'm looping through that long vector, and every 4 sets of values in that vector. PS, you need to look up what a vector is if you don't know. But each set of 4 values represents sort of the RGB content. So you have the first number is a red, second green, third blue. The fourth is the alpha channel. The alpha channel represents the transparency of that particular color. In our case, I didn't really care about it too much. I know that it could be, I just divided it by 255. I actually don't recall if that's what alpha usually can even get up to, but it doesn't really matter because for this purpose of this video, we don't really need it. What we really care about are the red, green, blue here, and so I'm dividing each one by 255 so that I can get a normalized value between 0 and 1. I'm adding them all together, and then I'm dividing it by 4. So what we'll end up with is, instead of 4 individual values representing 1 point, we will end up with a vector that represents every single pixel in our image. So in this case, it's 8 pixels by 8 pixels. So we will end up with a vector of 64 values, and each of those values will be a value between 0 and 1, and each of those values will represent a particular height, the height at that point on our image. So once we've done that, we can choose the maximum height that we want our data to be. So say we want the max to be 1,000, that's the maximum amount of height. That's the tallest. Maybe 1,000 meters is your measurement, and so 1,000 meters is the tallest it can possibly be. So this very, very white pixel will be 1,000 meters tall. This will be almost halfway between, so it'll probably be 500 meters, and the black will be 0 meters. So once you have that, we will have a vector that looks something like, so we'll have a vector that looks like this. There'll be 64 elements because it's an 8 by 8 pixel value, and we will turn it to XYZ coordinates. So the X at the 0 point will be 0, and this is the upper left corner, keep in mind. So it's starting from there, it's X equals 0, Z equals 0, but the Y equals 99 because it's a very tall or semi-tall spot. We can look at the image to remind ourselves. Let's see. Yeah, so this actually might be this point. Can't remember exactly how it's coordinated, but if we look here, we can find, one of the tallest points is this point. 688 is what I'm seeing. So that's probably going to be, one of these corners here. And as you can see, every row is made up of 8 of these values. And we're going one by one. We're going as X increases and then as Z increases down here. And all throughout, we have these Y values in the middle representing the actual height at that point. So once you have this, you can use this as sort of the terrain for your whether it's a game or some sort of model that you're building. But you can use this data to translate it into a mesh, say. And I'm planning on doing another video where I talk more about a mesh and how that works and how you can get this data into a mesh. But and there's a couple methods for actually translating this data and turning it into a mesh. So, but this is a height map. So this is what a height map is. You keep in mind it's just an image, usually a grayscale image, but it could be colored too. There could be a lot of, it could be red and orange and green, and you just have to decide like how exactly you extract the height data from those colors. And then once you take that image, you extract the data from it. So in our case, the RGBA values, and then you sort of use whatever method you want to translate that RGBA data into some sort of height data. And that's it. Hey, thanks for sticking with me to the end of my first video for this channel. Please let me know if there's anything you'd like me to talk about in the future. Cheers.